So I've gone over entanglement and a small, brief uh, algebraic build up of entanglement, and concluding that if all these objects equal some type of patterns of space-time, this allows an electron to remain the same mass after it's split in half, if you will, and for there to be two of them, and for them to all coalesce and equal of the original counterpart. And then adding together would obviously equal that counterpart times two. And then all of them being made up of space-time allows you to do all kinds of shenanigans that happen in quantum mechanics. I want to reiterate, these happen in quantum mechanics, these things. And the basic math I presented, it is not beautiful, it is not eccentric, it is not necessarily even quantum math, but it does express what happens in quantum mechanics from a purely algebraic. So with with space-time, on three particles, I'm going to now name these three particles TA, TB, and TC. Okay, so that gives a little distinction here. And what's the difference between EA and T? Well, all of these are also electrons, except for one, and that is the one that's going to be destroyed, which is particle C. So particle C is going to be destroyed. So in this case, TA equals TB, and TA equal TB expresses TB already, so that's good enough. And then TA does not equal, which in programming we use a exclamation point, does not equal TC. But what am I going to use for formatting that they are entangled together? So TA, but if TA, I'm going to have to use programming language to describe this. So if TA is entangled with, I'm going to use brackets, TA, TB, and TC, then T, well, fair enough. Then the expression is as before, SPC, SPT, SPT, and SPTC, because these do not share the same equals the of all of them together. And this one would be also the other qualities we can name off. We can name off their total magnetic energy, electromagnetic energy. And then finally, we put one more if statement. If TC, and for the record, any one of them could be destroyed, but we're talking about TC right now. If TC equals star, which is destroyed, if TC is destroyed, then TB equals TC. This is literally what's okay. So under these parameters, basically what's going on is the space-time is unraveling, SPT, and then C, the C that specifies um, TC space-time. The the unravel that I don't have mathematical terms to put in of results in TB equaling TC. And that is exactly what's going on with teleportation. The destruction of TC, the unraveling of space-time, results in TB's transformation to become TC. And the effect is result equals TA entangled with TC. In TB's position. One could say that TB was destroyed actually in position in place of TC's. And there's a lot of things you could say, but eventually the effect is TA is entangled with TC in TB's position. Teleportation. And this expression allows for intuitive thought with, like, for example, quantum tunneling. So in this case, the unraveling of TB and TC causes them to interchange, or the unraveling of TB and TC, I'm saying that it happens simultaneously, causes TB to become TC. But either way, TB becomes TC. And either way, TC goes into TB's position. And for all intents and purposes, it expresses the same thing. And this also is a fact that teleportation in quantum mechanics happens, but more so that there is another violation of the law of conservation of energy. That's two, beyond the fact that gravity does it anyways. And that violation is that fucking TC or TB was destroyed. And so the assumption is that the energy was used to replace the two, but we don't know where the energy actually went. Unless, again, unless SPT equals energy, space-time equals E. And if space-time equals E, then lots of things can unfold. If space-time equals E, you can go from relativity to quantum mechanics in a lot of lucrative and creative ways. It doesn't get you from relativity to quantum mechanics or quantum mechanics to relativity necessarily, but it gives you values that might be able to interchange between the two.